Imagine this. You're standing on the surface of a neutron star. The gravity is so intense that your body feels like it's being pulled in every direction at once. But you're not crushed instantly. No, you're still alive. You're equipped with the most advanced technology ever created, something that allows you to survive in the most hostile environment known to humankind. For just 1 second. In that single brief moment, what would you experience? Could your senses even keep up with the overwhelming forces at play? Neutron stars are among the most extreme objects in the universe. They are the remnants of stars that were once far more massive than our Sun. When these stars die in a catastrophic explosion called a supernova, they collapse under their own gravity. The result? An object that is only about the size of a city, but contains more mass than the Sun. This results in a gravitational pull so powerful that it warps space and time around it. To put this into perspective, if you could stand on the surface of one, the force of gravity would be around 200 billion times stronger than what we feel here on Earth. In a single second, you would fall thousands of kilometers toward the star's center, only to be crushed by its unimaginable density. What would it feel like to stand on such a star, even for just a moment? The idea of surviving, let alone experiencing such a thing, seems absurd. Yet that's exactly what we're here to explore today. Before we dive into the science and physics behind neutron stars, let me take a brief moment to connect with you. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning its exploration of the universe, and your support means everything. If you've ever wondered what it's like to peer into the deepest corners of the cosmos, to ask the impossible questions, and to seek answers from the very fabric of space-time itself, you're in the right place. So, if you enjoy unraveling these mysteries with us, hit that subscribe button. It's free and it helps us grow this community of explorers together. Now let's get back to the question at hand. What would happen if you could survive on a neutron star for just 1 second? This isn't science fiction. It's a thought experiment based on the incredible physics we know today. So, buckle up, because we're about to embark on an extraordinary journey, a journey that takes us to the very edge of what we think is possible. The deadly attraction of a neutron star first. Let's break down the core of this scenario. A neutron star is a collapsed stellar remnant, a city-sized ball of neutrons that was once part of a massive star. When a star dies in a supernova explosion, the outer layers are blasted into space and the core collapses under the force of its own gravity. As the star's core compresses, electrons and protons merge to form neutrons, creating a hyperdense object that can contain up to twice the mass of our Sun, but within a radius of only about 10 kilometers. To visualize this, imagine squeezing the mass of the Sun into an object the size of a large city. The result is the formation of a neutron star. The gravity on a neutron star's surface is so intense that it warps the very fabric of space-time around it. If you were to stand on its surface, time itself would behave differently for you compared to someone on Earth. But gravity isn't the only thing that makes neutron stars so extraordinary. It's also their incredibly high density, intense magnetic fields and extreme temperatures. The gravitational field on the surface of a neutron star is around 200 billion times stronger than Earth's. To put this into perspective, on Earth, if you drop an object, it will fall at a certain rate due to gravity. On a neutron star, objects would fall at an insane speed in the blink of an eye. The immense gravitational force would stretch and compress your body in ways that defy imagination. But gravity is just the beginning of the story. Neutron stars are also highly magnetic. Some of them, known as magnetars, have magnetic fields 1,000 trillion times stronger than Earth's. These magnetic fields are so intense that they can bend light and distort nearby space, creating an environment unlike anything we experience on Earth. So not only are you dealing with gravity that could crush you in seconds, but you're also surrounded by powerful magnetic forces that could tear apart even the most advanced technology. Then there's the temperature. The surface of a neutron star can reach temperatures of over 600,000 degrees Celsius, hotter than the core of our Sun. The energy released by the star's intense heat and radiation would be enough to incinerate any living being in an instant. Even the toughest heat shields, created from the most advanced materials we have today, would be useless in the face of such extreme conditions. In this scenario, your body would be exposed to lethal radiation levels. Neutron stars emit bursts of gamma rays, X-rays, and other high-energy radiation. The amount of radiation near a neutron star would be enough to disrupt the molecular structure of your cells and DNA, causing irreparable damage. It wouldn't be long before the extreme radiation and the physical forces at play would begin to disintegrate your body. You'd be subjected to what scientists call spaghettification, an effect similar to what happens near black holes, where the gravitational pull becomes so strong that it stretches and elongates objects. However, let's imagine you somehow manage to survive this onslaught of forces for 1 second. The question is, how would your mind and body even process such an intense moment? Would the experience feel like eternity? Or would it be so overwhelming that you wouldn't have time to comprehend what was happening? In this split second, everything you know about physics would be shattered. Your body would be crushed by gravity, scorched by heat, and destroyed by radiation. The environment around you would be chaotic, distorted, and impossible to fathom. It's the kind of extreme environment that no human could survive in the conventional sense, but it's also a place that pushes the boundaries of what we understand about the universe. Now that we've begun to scratch the surface, you can see why surviving for even a second on a neutron star is a mind-bending thought experiment. It challenges everything we know about life, death, and the nature of the cosmos. But what if we could somehow survive these extreme conditions? What if technology advanced to the point where this kind of journey could become possible, if only for a moment? This is where our story gets even more intriguing, because despite the overwhelming odds, the dream of exploring neutron stars and other extreme cosmic objects isn't as far-fetched as it seems. So, with that in mind, let's dive deeper into the science of neutron stars, the forces at play, and explore the possibilities for surviving in one of the most dangerous places in the universe. As you stand on the surface of this incomprehensibly dense object, it's easy to feel like you've entered another realm altogether, a place where the laws of nature are pushed to their absolute limits. The first thing you'd notice? The sheer gravitational force pulling you toward the stars' core. The ground beneath your feet is not like Earth. It's not solid in the traditional sense. Instead, it's a realm of unimaginable density, where matter behaves in ways you would never have thought possible. The immense force of gravity on a neutron star's surface is so extreme that it warps space-time itself. To truly understand how crazy this environment is, let's break it down further. A neutron star's gravity is about 200 billion times stronger than Earth's. This isn't a small difference. It's the kind of force that distorts the very fabric of space around it. If you were to look up at the sky, the view would be radically different. Because of the strong gravity, light itself would bend and warp. You might look out into space and see stars distorted, stretched, or even duplicated as light paths curve around the neutron star. It's almost like living in a giant gravitational lens where the normal rules of vision and perception don't apply. Imagine the stars near you in space. What would be a single point of light on Earth would look like a stretched arc of color, bending around the massive gravity well. This bending of light is called gravitational lensing, and it's a real phenomenon, predicted by Einstein's theory of general relativity. But on a neutron star, this effect would be so intense that space itself would feel alive, almost as if it's breathing. Now let's dig into the core of a neutron star. What makes it so uniquely powerful isn't just its size or density, it's what's going on beneath the surface. When a massive star dies in a supernova explosion, its core is crushed to the point where electrons and protons are squeezed together to form neutrons. The result is a star made almost entirely of neutrons, hence the name neutron star. These neutrons are packed so closely together that they're nearly as tightly packed as you can get, without the core collapsing into a black hole. At this point, everything we know about matter changes. Neutrons themselves are subatomic particles, normally part of atoms. But here they exist in vast numbers, creating a star that's incomprehensibly dense. Imagine that a single teaspoon of this matter would weigh over 6 billion tons. To put this into perspective, that's roughly equivalent to the weight of a mountain the size of Mount Everest packed into a tiny teaspoon. The density is so extreme that it defies common sense. This is not matter that behaves like anything we encounter in daily life. The intense compression of matter inside a neutron star also means that atoms themselves break down. The structure of atomic nuclei gets crushed, and you're left with a dense, almost supermatter that no human has ever seen. In fact, the interior of a neutron star is unlike anything we can recreate on Earth. The physics here are beyond even the most extreme laboratories on our planet. The sheer density and the types of forces at play are an exploration of a whole new realm of physics. But the gravity itself isn't the only mind-boggling feature of a neutron star. There's something else, something just as intense hovering around the star. Its magnetic field. Magnetic fields are a force that's familiar to us on Earth. We use them in everything from compasses to electronics. But the magnetic fields around neutron stars, they're in a whole different league. Neutron stars can have magnetic fields that are 1,000 trillion times stronger than the Earth's. These fields are so powerful that they can bend light and even alter the very trajectory of charged particles. If you were standing on a neutron star, if we can even imagine that, you'd be bombarded by these magnetic fields. They would twist your senses, distort your surroundings, and have a profound effect on the technology that might protect you from the other dangers of the environment. Imagine this. As you stand there, you might feel a tingling sensation, not from static electricity, but from the unimaginable magnetic forces that are flooding your body. Any electronic equipment you have would be at serious risk. The magnetic field would scramble signals, disrupt communication devices, and possibly even short-circuit anything that relies on electronic circuits. And it's not just the devices. Your body itself might experience effects you can't even begin to comprehend. If you've ever experienced the slight tingling of a magnetic field on Earth, imagine that sensation multiplied by trillions. But the most important thing to understand is how these forces affect time itself. If you could somehow escape the crushing gravity and powerful magnetic fields, there's still another twist. Time dilation. Time dilation is a concept we often associate with the warped space-time around black holes, but neutron stars are no different in that regard. The immense gravitational pull of a neutron star bends space-time so dramatically that time near the surface would flow slower compared to places farther away. If you were on the surface of a neutron star, a second for you would feel like several seconds or even minutes for someone far away, like an observer on Earth. Imagine being trapped on this world where time is not only distorted, but fundamentally altered by the forces around you. So far we've explored the gravitational forces, the mind-bending density, and the warping of time. But one of the most surprising characteristics of a neutron star is its temperature. The surface of a neutron star isn't just extremely hot, it's mind-blowingly hot. Temperatures can reach up to 600,000 degrees Celsius, far hotter than the sun's surface. To give you some perspective, the core of our sun is about 15 million degrees Celsius. Even the hottest stars in the universe don't come close to the heat on a neutron star. But here's where things get even more interesting. Because of the neutron star's extreme heat, it releases an enormous amount of energy in the form of X-rays and gamma rays. The radiation would be unlike anything you've ever experienced, unbearable, intense, and completely destructive. In fact, any form of life near a neutron star would be exposed to radiation levels far beyond what we experience on Earth. The radiation alone would likely be enough to kill you instantly, regardless of how advanced your technology might be. To survive, you'd need something far beyond the best spacesuits we've ever designed. Imagine being exposed to radiation levels so high that even the hardest materials we've created on Earth would be vaporized in an instant. The sheer intensity of this energy would overwhelm anything you thought you knew about heat, radiation, and survival. You'd be a mere speck in the face of cosmic forces far beyond our comprehension. This is what it means to be on the surface of a neutron star, an environment so extreme that survival, even for a second, seems impossible. And yet it's also an environment that invites endless curiosity. It's a place where the most fundamental laws of nature are pushed to their limits, where matter and energy behave in ways we cannot even imagine. So we've already painted a picture of just how mind-bendingly hostile the environment of a neutron star is, from gravity so powerful it distorts space and time, to temperatures that would melt any known material, and radiation levels that would fry you before you could blink. It's clear that this is a place where no human could survive, at least, not in the traditional sense. Yet we're still asking the question, what if? What if there were a way to survive even for just 1 second? Let's take a step back and dive into the world of theoretical technology. Because while it seems impossible, the idea of survival in such extreme conditions isn't entirely out of the realm of imagination. For this to work, we'd need technology so advanced it would require not just a leap in science but a total revolution in our understanding of physics and engineering. But what would such technology look like? And more importantly, how could we even start to conceive of surviving the deadly forces of a neutron star, if only for a brief moment? The first thing we'd need to consider is the immense heat. With the surface temperature of a neutron star reaching upwards of 600,000 degrees Celsius, conventional materials would vaporize in an instant. Spacesuits, even the most advanced ones we could create, would be utterly useless. But let's imagine a material, a perfect material, that could withstand this blistering heat. Scientists have theorized about materials that could potentially handle these extreme conditions. One possibility might be graphene, a single layer of carbon atoms arranged in a hexagonal lattice. Graphene is incredibly strong, stronger than steel, and it can withstand high temperatures, even exceeding what we experience on Earth. Some theorists suggest that, with enough breakthroughs in material science, a spacesuit could one day be built from graphene or other ultra-durable materials that could survive the intense heat of a neutron star's surface. But here's the catch. This wouldn't be just a regular suit. To withstand the radiation, the suit would need to be coated with materials that could block out high-energy gamma rays and X-rays, radiation that could easily tear apart any traditional protective gear. Another possibility is nanotechnology, where microscopic machines or robots could be built to reinforce the structure of a suit or even directly manipulate the environment around the wearer. Imagine a nanotech suit that could actively reconfigure itself, drawing on the resources in its immediate environment to reinforce weakened areas or to cool down hotspots. Nanobots could repair and maintain the suit's integrity, essentially, making it alive in its own right, a suit that responds dynamically to the dangers around it. The suit could even draw on a miniature super-efficient power source, perhaps based on the concept of nuclear batteries or fusion cells, to generate the energy needed to power life support systems and keep the wearer alive in an environment where death would be instantaneous for most others. However, there's one more challenge we need to face: the gravity. The gravitational pull of a neutron star is so intense that standing on the surface would feel like being crushed under the weight of 100 Earths. The human body, even with a supersuit, would be torn apart by this pressure. But what if we could counteract this gravity, even if just for a second? One of the most promising ideas comes from anti-gravity technology, which remains purely theoretical for now. Scientists have been exploring the idea of creating a system that could generate a force strong enough to counteract gravity. But it's still a long way off. In theory, using something like electromagnetic fields or gravitational shielding could reduce the effects of gravity, allowing a person to stand on the surface of a neutron star, if only for a moment. However, we're still in the realm of science fiction when it comes to this technology. To make it work, we would need to manipulate the very fabric of space-time, bending it in a way that would offset the star's gravitational pull. Let's entertain the possibility that, with future breakthroughs, we could develop a kind of gravitational shield. This shield would interact with the intense gravitational field of the neutron star, creating a localized zone where gravity's effects are reduced or neutralized. Think of it as a futuristic, super-powered version of a force field, one that could block or even reverse the impact of gravity. But even with such a shield, we would still be faced with the problem of spaghettification, the stretching and elongating of objects in intense gravitational fields. Unless this shield could completely negate the tidal forces at play, we would still face the risk of being torn apart. So how would we mitigate that? One possibility might lie in adaptive pressure suits that could respond to extreme pressure. These suits would actively redistribute the force of gravity, so the wearer's body would remain intact, or at least avoid being crushed. The suit's material would need to be incredibly flexible and durable, able to shift its internal structure, to absorb and redirect the gravitational forces. Then there's the issue of radiation. Even if we manage to block the heat and withstand the gravity, there's still the intense electromagnetic radiation to contend with. Neutron stars release high-energy gamma rays and X-rays in bursts that can damage cells and DNA within fractions of a second. To shield from this, we'd need an electromagnetic shield, one capable of deflecting or absorbing radiation on an atomic level. Again, this brings us into the realm of advanced material science and nanotechnology, where the future of protective suits might lie in designing materials that interact with radiation in ways we've yet to fully comprehend. But let's say, for a moment, that the technology exists and you're now equipped with the most advanced reality-bending suit ever created. You're on the surface of the neutron star. You take that first step. The gravity feels almost manageable. Your suit shifts and adjusts to keep you from being crushed. You feel the oppressive pull of the star, but it's not tearing you apart, yet. You stand tall for that one precious second, your body encased in a shield of science fiction come to life. What would you experience in that fleeting moment? Would it be awe-inspiring? Terrifying? A mixture of both? The radiation would be so intense that your skin would feel like it's burning, but the suit shields you. Barely. Your eyes would be flooded with the most intense light, the sky bending and stretching in impossible arcs. Time would seem to slow and your senses would be overwhelmed. It would be the ultimate moment of human exploration, a place where technology and human willpower meet the raw, unforgiving forces of the universe. And yet, it would only last for a second. 1 second. A second that would be frozen in time. A moment when human ingenuity and the wonders of the cosmos collide. Now let's zoom out and consider the bigger picture. You've braved the unimaginable. You've stepped onto the surface of a neutron star, armed with advanced technology that allows you to survive the crushing gravity, the scorching heat, the bending light, and the radiation. You've glimpsed the raw forces of nature, forces that transcend everything we thought we knew about physics. But what would we, as a species, actually learn from such an impossible encounter? What could humanity take away from a single second on a neutron star? The first and most profound lesson might be the limits of human endurance and the nature of reality itself. For centuries, we've pushed the boundaries of space exploration, always striving to go farther, to understand more. But stepping onto the surface of a neutron star, an object so alien, so extreme that it defies comprehension, would force us to confront the very nature of our existence. It would show us just how fragile we are in the grand scheme of the universe. A neutron star, with all its power and mystery, is a cosmic force that has no concern for us. Yet, the fact that we even consider surviving such a moment would be a testament to the resilience of human curiosity. Surviving this extreme environment, if only for a second, would offer us a glimpse into what might lie beyond our current scientific understanding. It would challenge the very foundation of our theories about space, matter, and time. What if in those brief moments we could observe phenomena that we could only theorize about? Could we directly measure the bending of space-time? Could we detect subtle gravitational waves or even unlock the mysteries of quantum physics at a scale we've never before seen? In that single fleeting second, we might witness phenomena that would rewrite the laws of physics as we know them. But it's not just about survival. There's another level to this, an intellectual revolution. By surviving on a neutron star, even for the blink of an eye, humanity would be propelled into an era of exploration unlike anything we've seen before. It would unlock the next stage of understanding about extreme astrophysical objects. Think about the black hole. For years, we could only study black holes indirectly. It wasn't until recently that we captured the first image of one, thanks to the Event Horizon telescope. But imagine the possibilities if we could study neutron stars directly, collecting data that we couldn't get any other way. What new technologies could arise from this? Just as space exploration led to the development of everyday technologies we now take for granted, from satellite communication to memory foam, the extreme conditions of a neutron star could push material, science, quantum mechanics, and energy production to entirely new heights. The technological innovations that might spring from the need to survive a neutron star could fuel a new wave of scientific discovery. And there's something else we need to consider: the implications for space travel. If humanity could somehow survive such a place, even for a moment, it would open up new doors for deep space exploration. After all, neutron stars are scattered throughout the universe, especially in areas where space travel could take us, like the remnants of supernovae. They're far from the boundaries of the solar system, but if we were able to survive for even a second on one, it would signify that we've broken through the most extreme barriers to human exploration. We could begin to think about missions to the furthest reaches of space, perhaps even venturing into the heart of galaxies where neutron stars dominate the landscape. But let's take it a step further. What if we're not just talking about survival for a second, but longer-term survival? What if, in the distant future, our descendants could live on or near these stars, adapting to these environments and thriving within them? Would it be possible to build entire colonies or research stations near neutron stars, taking advantage of their extreme conditions to power new forms of technology or harness their radiation for energy? Could neutron stars themselves become the key to unlocking clean, unlimited power for the future? This brings us to one of the most fascinating aspects of neutron stars: the potential for harnessing their energy. Neutron stars, especially those in binary systems, can emit incredible amounts of radiation in the form of X-rays, gamma rays, and even strong bursts of matter. This energy could, in theory, be harnessed using the most advanced energy conversion technologies. Imagine an energy source so powerful that it could provide for entire civilizations, a limitless supply of energy harvested from the very heart of the universe's most extreme objects. Perhaps we're even getting a glimpse into the future, a time when humans don't just observe the universe from the comfort of Earth, but actively engage with it, bending it to our will. If we could survive on a neutron star, it would mark a turning point for humanity, a leap from passive observers of the cosmos to active participants in its grand design. But let's pause for a moment and consider the most profound takeaway from such an experience. What would stepping foot on a neutron star teach us about the fragility and resilience of life? After all, we're talking about survival in one of the most extreme environments in the universe, an environment where the forces of nature are so powerful, so unforgiving, that they could reduce us to nothing in the blink of an eye. And yet, in this impossible scenario, we're also forced to confront the incredible resilience of life itself. Humanity is the product of billions of years of evolution on a relatively hospitable planet, and we've overcome so many challenges already. If we could survive for even a second in such an extreme place, it would be a profound testament to the unyielding drive to explore, survive, and adapt. But here's the real kicker. As we continue to push the boundaries of science and technology, we begin to understand that life is far more adaptable than we think. Neutron stars, black holes, and other cosmic phenomena might seem like impossible frontiers, but they are also incredible laboratories for the unknown. They challenge us to think beyond our current limitations, and in that process, we may discover new forms of life, new materials, or new physics that we never dreamed possible. So as you imagine what it would be like to survive on the surface of a neutron star, even for that brief fleeting second, ask yourself this: what's next for humanity? Could this moment of survival be the beginning of a new era in exploration? And if we can survive the most extreme environments the universe can throw at us, what other mysteries could we unlock along the way? As we wrap up this journey, I invite you to reflect on the extraordinary possibilities that the future holds. If we can dare to imagine surviving in places as extreme as a neutron star, what other frontiers of the universe await our exploration? The answers might be even more incredible than we can imagine. If this video sparked your imagination, leave a comment below and share your thoughts. What do you think would happen if we could survive a neutron star for a second? And if you enjoyed this cosmic journey, hit that like button and share it. with your fellow explorers. Keep the conversation going because who knows, maybe the next discovery we make will push us closer to these unimaginable realms. Thanks for watching, and as always, keep your curiosity alive. The universe is waiting.